Okay, I wanted to start, we can look at, let's look at number 7. 7 from your homework last night. So if you haven't done it yet, you need to write this problem down. This is number 7. This is going to recap what we did yesterday in class. The problem says x to the 3/4 is equal to 27. Okay, and we're solving for x here. And we got to go back to the idea that if I had x squared last week, what we did to undo that squaring was square root, right? Which is the same thing as raising it to the half power. And we know that the reason those two operations undo each other is because when I raise a power to a power, I multiply my exponents. And 2 times 1/2 makes 1, right? And we had the conversation, well, what if I had the third power, right? X to the third power. Well, how would I get rid of a third? Multiply by, or raise it to its reciprocal power, which would be a 3, so that I can cancel them out, right? What if I had something to the 2/3 power? I want to cancel it. So I raise it to its reciprocal power, 3/2. Okay, this is the idea, and this is why it works to raise an exponent to its reciprocal power, because then I'm left with only the variable. So in order to cancel off this 3/4 that's in the top of this power, we're going to raise it to the 4/3. That is not to say we are raising or multiplying it by 4/3. Okay? Everybody be clear about that. We are not multiplying x by 4/3. We are raising it to the 4/3 power. The reason we do that is because the 3/4 times the 4/3 makes 1. So I'm left with x. This problem will fall off the boat if you don't raise the 27 also to the 4/3 power, right? What I do to one side, I have to do to the other. Again, we're not multiplying by 4/3. We are raising 27 to the 4/3 power. So when I'm raising to a rational exponent, this goes back to the rule that says a to the m over n power is equal to the nth root of a to the m power. So if we were going to rewrite this 27 to the 4/3, we could call it the cubed root of 27 to the 4th power. Oh. Right? Oh, light bulb. So what is the cubed root of 27? 3. So x is going to equal 3 to the 4th power. So that's 2 pairs of 3s, okay? I always do the 4th powers like this. 3 times 3 is 9, and 9 and 9 make 81. So 3 to the 4th would be 81. I do that the same for 2. 2 to the 4th is 16. 4 times 4, 16. Nine times 9, yeah, 81. Okay, so I think that would be very handy if you had some rules written down, some exponential numbers, okay? When we start cube rooting or trying to find the 4th root or the 5th root, it's nice if we know those in our head. So write these down with me, okay? Let's do 2 squared is 4. Don't y'all know that? Yeah. What about 2 cubed? 8. How about 2 to the 4th? 16. 2 to the 5th? 32. 32, 2 to the 6th? 64. 2 to the 7th? 128. Okay, so that's kind of as far as we go in 2s. We don't usually go higher than 2 to the 7th in these type of problems. So I think if you can know your 2s through 2 to the 7th, you'd be in pretty good shape. Let's do 3s. 3 squared 9. 3 cubed, 27. We just did 3 to the 4th. We don't usually go higher than that. We might see 3 to the 5th, in which case that'd be 81 times 3. 243. I know for sure we're not going to go higher than 3 to the 5th. Okay. Let's do some 4s. 4 squared. 4 cubed. See, I have to start doing like this. 64. How about 4 to the 4th power? 256. That one might come up. It's a really, really small chance. 256. We will sure not see 4 to the 5th. Okay. And for 5s, 5 squared, 25. 5 cubed, 125. How about 5 to the 4th? Anybody? 125 times 5? I think this one's 625. Okay. I would say if you can know these, you'd be pretty set on these kinds of problems where you have to take the cubed root of whatever or the 5th root of whatever. Any questions on these? Everybody okay? Okay. All right, so in a semi-related topic, we can look at number 9. Number 9 for this assignment that you had for homework last night. Number 9 says this: x minus 1, close parentheses, to the 3/4 power is equal to 8. X minus 1, close parentheses, to the 3/4 power is equal to 8. Okay. And we'd like to be able to solve for x. Right now, x is inside parentheses raised to a power. So if we're going to solve, we have to follow PEMDAS backwards, right? I'm not going to be able to get into the parentheses until after I have dealt with the exponent. SADMIP. PEMDAS backwards. SADMIP. I've got to do the exponent before I bust into the parentheses. Yeah? Okay. So how do I handle the exponent? Raise it to the 4/3 power on both sides. So we're going to raise 8 to the 4/3 power. So we have x minus 1 equal to, and that's how we get rid of both powers, equal to, we could do the cubed root of 8 to the 4th. You could go ahead and simplify on the right side. I'm fine with that. X minus 1 is equal to, what is the cubed root of 8? 2 to the 4th. X minus 1 is equal to, what is 2 to the 4th? 16. 16. So now we add that 1. Last step. 17. X is 17. Not so bad?
Awful.
Okay. All right, and now we're going to look at one other type of situation here. And this is going to be example 3. Example 3, this isn't one of your homework problems. This will help you do your homework problems. Okay. And our instructions here say solve. Plain and simple. Solve. And what we're going to be solving is 3. What we're going to be solving is 3x to the 3/4 is equal to x to the 1/2. Three x to the 3/4 is equal to x to the 1/2. So now I've got variables with powers on both sides, and they're not the same power. So as far as raising it to the reciprocal power, I don't know what to raise it to. Do I raise both sides to the 4/3? Do I raise both sides to the 1/2? We don't know. So the move here instead, we're going to write it down in steps. We're going to do step 1, set equal to 0. We want to get everything on one side, which means we're going to subtract the x to the 1/2 from both sides. Okay, that's how we're going to get it over yonder. So we're going to have 3x to the 3/4 minus x to the 1/2, all equal to 0. Everybody okay? Our next thing we want to do is we want to rewrite the powers as fractions with common denominators. We want to rewrite the powers as fractions with common denominators. Okay? So right now I have 3x to the 3/4 minus x to the 1/2. What I need is for 3/4 and 1/2 to have the same denominator. What would be the common denominator there?
2/4.
4. So we're going to change the 1/2 to be 2/4. So when we rewrite, we're going to have 3x to the 3/4 minus x to the 2/4 equals 0. Now we're in a position where we could pull a GCF. Okay? The way that you can see the GCF, we're going to factor out a GCF. You can't see the GCF unless both of your fractions have the same denominator. You can't tell what it is. Okay? But now I'm looking at both terms, and both terms have what?
2/4.
X to the 2/4. One of them has x to the 3/4. The other has x to the 2/4. But the greatest common factor that's in both is x to the 2/4. Can you tell that? So we're going to pull x to the 2/4 to the very front. What is that going to leave out of the first term? 3x to the 1/4. Okay, so this is twisty. What's happening is when I'm dividing my bases, remember I divide, when I factor out, I'm dividing. So I'm taking x to the 3/4, essentially x to the 3/4 divided by x to the 2/4. And the rule when I divide like bases is I do what? What do I do with my powers? Subtract them. When I divide like bases, I subtract my powers. So to figure out what's left here, this 1/4, you could do 3/4 minus 2/4, and I'm left with 1/4. That's why it's x to the 1/4 left over. Okay? You're always subtracting your powers when you're dividing out a GCF. That's why it's handy to see them as common denominators. What's left out of the second piece? If I pull x to the 2/4 out to the front, what's left? 1. 1. Why is it 1? Because x to the 2/4 divided by x to the 2/4, the same thing on the top and the bottom of the fraction. It's not 0. It's not nothing. That fraction with the same numerator and denominator is 1. So what's left over here? 3x to the 1/4 minus 1 equals 0. Everybody okay so far?
If we factored out an x,
Wouldn't it be 2x?
If we factored out an x.
2x 1/4.
yeah, since we factored out the x.
No, we didn't factor out the 3. Look up here. If I wrote, let's go back up here to this piece right here. Put the 3. 3x to the 3/4 divided by x to the 2/4. What's left on top? The 3. You see that it didn't change?
Yeah.
It only affects when it's raised to.
Uh-huh. Only affects what it's raised to. So we would be left with 3x to the 1/4. There's nothing for the 3 to get divided by. It's still a 3. I don't know why, but somehow when we start putting fractions in here, it gets altogether different than it was. Okay, so I'm going to put what we just figured out. We had x to the 2/4, open parentheses, 3x to the 1/4 minus 1 equals 0. Now our job is to set both factors equal to 0. Both factors. So remember, you can pull the cupcake, but you can't eat it. So we've got to set that x to the 2/4 equal to 0 and solve for x. How do we get rid of that 2/4 power?
4/3 of the x squared.
Okay, or I could raise it to the 4/2 power. Right? Raise it to the reciprocal power. What's the reciprocal of 2/4? 4/2, also known as 2. 4/2. So these cancel and leave me x. What is 0 raised to the 4/2 power? 0. So one of my solutions is x equals 0. Okay. Remember, if you pull a GCF and there is an x involved, you're going to have a 0 in that situation, and you better set it equal to 0. If you pull a GCF and it's just a number, there's nothing there. You can divide that number on both sides, and 0 divided by that number is just 0. So the number goes away. But if there's an x involved when you pull the GCF, then you're going to get a linear factor out of that. Okay. All right, let's set the other piece, this right here, equal to 0. We have 3x to the 1/4 minus 1 equal to 0. What's next?
Add 1.
Add 1 to both sides. So 3x to the 1/4 equals 1. Almost. Almost. Right now, this 1/4 is just a hat to x. It's not in an umbrella situation where I have to deal with that first.
Divide by 3.
Divide by the 3, then we're going to raise it to the new power. So we have x to the 1/4 equal to 1/3. And how do we get rid of that 1/4? Raise it to the reciprocal. What's the reciprocal of 1/4? 4. Do the same to both sides. Raise it to the 4th power. So we're left with x is equal to, how do I handle 1/3 to the 4th power? Anybody remember when I divide a quotient raised to a power? No. What happens? Don't remember. If I have a over b to the power of x, that becomes a to the x over b to the x.
Yeah.
Both pieces get the power. So in this case, we'll have 1 to the 4th over
3 to the 4th.
3 to the 4th,
Which is
1 over
81.
81. So our answer here is x equals 1 over 81.
Oh, yeah, that's a complicated one.
That's a lot, isn't it? I think we ought to do another one, just to make sure that we're not spinning out on our homework. It won't be so bad once you get what we're doing. All right, so this is number 8 from your homework. Number 8. It says 2x to the 1/2 minus x to the 1/4 is equal to 0. 2x to the 1/2 minus x to the 1/4 equals 0. So from the example, our first step was set it equal to 0, right? This one's already equal to 0. Look back at your notes. What did we do next? Before we could factor out the common denominator, or the GCF, we had to rewrite it with common denominators. Okay, so don't factor anything out until after we've rewritten it. So we've got a half and a quarter. A half and a fourth. What's the common denominator need to be? 4. So how could we rewrite x to the 1/2 if we wanted to be a denominator of 4? X to the 2/4. Multiply both the top and the bottom by 2 and we get there. Minus x to the 1/4 equal to 0. Now you can see what the greatest common factor is. Anybody know?
1/4.
X to the 1/4. X to the 1/4. So we'll pull the GCF to the front. X to the 1/4. What's left out of the first term? 2x to the 1/4. Remember, you get to subtract the powers when you pull the GCF. So 2/4 minus 1/4 leaves me 1/4. Minus what's left out of the second term? 1. Good. Not 0. Now what?
You make that x equals 0.
Yeah, set each piece equal to 0. So my first piece is going to be x to the 1/4 equals 0. How do I solve here?
Reciprocal.
Raise it to the reciprocal power. What's the reciprocal of 1/4?
4.
Okay. So we cancel the powers here.
0, 0.
X equals 0. Good. And the other one is going to be our 2x to the 1/4 power minus 1 equal to 0.
Add 1 plus 1.
Okay, add 1 to both sides. So 2x to the 1/4 power equals 1. And then
Divide by 2.
divide both sides by 2. So x to the 1/4 power is equal to half. And then
Reciprocal.
raise both sides to the reciprocal power, which is 4. So x is going to equal 1 to the 4th over 2 to the 4th, also known as 1/16. 1/16. So your final two solutions are x equals 0 and x equals 1/16. Questions there? No? No? Okay, I think that sets you up to get the rest of your homework done. There's not very much left. Okay, you have the rest of the class period to do that, and then we'll grade it first thing tomorrow.